All right, so welcome to launching the LFEdge end user community. We are glad you could join us. My name is Brett Preston, and I will be one of your hosts today. Joining me, my colleagues Jill and Aaron, helping to moderate some of the Q&A, along with several of our speakers and panelists. This is the first of two kickoff events for this end user initiative, the second of which we will provide a little more information during the presentations. We have several use cases lined up for you today, including automotive, manufacturing, and telco. And just a few notes before we start. This session will be recorded with materials posted to the LFEdge wiki following the call. For questions, we will utilize the Q&A feature in Zoom. I think for most, it'll be in the lower toolbar of your Zoom windows. It may be in the upper toolbar depending on browser as well. But you'll see that Q&A feature. And depending on flow, we may take some live questions after the last panel. Should we activate and take live questions, you'll use the raise hand functionality that Zoom also provides. And so without further ado, allow me to introduce Arpit Joshipura, a GM of Edge IoT and Networking at the Linux Foundation, and Jason Shepard, LFEdge board member and VP of Ecosystem at Zedata to get us started. Arpit?
Very good. All right, so we have a very packed agenda today, and I think we want to make sure that you get a lot of questions answered here. I'm really excited to show and walk you through the bigger LFEdge and Edge market in general and what we have accomplished. And Jason and I will be sort of spending a little bit of the time upfront setting this up. Because there's definitely a challenge of defining what an end user is, who a vertical is, and more importantly, what is an edge. And I think we've accomplished quite a bit on that as a community. So thank you for participating. In 2018, when Edge was kind of new, this chart was very popular. And it essentially said that because of 5 technology building blocks, right? Whether it's 5G, microservices that allowed for app portability, AI for allowing for predictive maintenance type things, as well as all the hardware acceleration that came at a fairly decent cost. And then the 5th final thing, which was kind of the on-demand network that got added. A whole series of new applications would emerge, and I'm using the word would, in 2018 that would demand lower latency and accelerated processing. And those applications could be on the telecom side for wireless or wireline or enterprise. They could be on autonomous device sides, immersive experiences, IoT analytics. That was just a vision, right? Now, the good news is in the last 2 years, the industry has moved forward, matured, and with the help of you all in the community, as well as a lot of analysts, we have narrowed down several of these use cases and established an important factor that allows for these use cases to prosper, right? But before I get into that, an important factor that came around was the pandemic. And all of a sudden in this new normal, Edge became even more critical, right? In a lot of industries. And then 5G became a lot more critical. So what we have been saying is that Edge is 4 times the size of the cloud market, according to several analysts. And now analysts are starting to quantify this market significantly. So let's go to the next slide and I'll show you how applications and use cases are kind of narrowing down. KPMG came out and said, there's a lot of software required in several of these industries, healthcare, industrial, transportation, environmental, gaming, etc. And on the right, our community focus in a priority list was industrial, energy, oil, gas, commerce, retails, etc. So we were kind of narrowing in on as a community, which vertical markets and groups will benefit the most from the edge compute revolution, right? And what's the best way to serve them? So this was one view that just came out. Another view that came out, if you go to the next slide, is from our friends at IoT Analytics, right? And this is again an IoT specific view, and you may have heard me say this multiple times, right? Not all IoT requires edge, and not all edge is for IoT. So we got to understand that edge is a horizontal concept, and Jason will come right with me in a couple of minutes and explain the terminology and the definition and all the work that the community has done to allow for a crisper definition. But in this IoT-centric view, you can see that the markets are fairly similar. The three big changes are the three red arrows that actually are going down in terms of the market trend. And primarily, this is direct impact of the pandemic, right? Smart cities, buildings, others, etc. But everything else is kind of going up. And I think this is a fairly accurate picture of the killer apps, right? Again, manufacturing, industrial, transportation, mobility, energy, retail, some of the top markets. If you go to the next one, there was another view that came from our friends at 451 Research, and I showed this at the ONES keynote. This actually has taken all the use cases now in several of these verticals and established both a horizontal and a vertical solution, right? So solutions for the specific target market, as well as generic solutions that can go across markets. And they have sorted this down by kind of bandwidth and latency, which are two very important factors for the edge market to proliferate. And I'm pleased to report that we are very much in line with this view, as a lot of the blueprints and a lot of the horizontal solutions with the focus on vertical blueprints are being addressed in one of the top two projects called Akraino. And I think I should mention that EdgeX Foundry is the other stage 3 project that includes a lot of IoT framework use cases as well. So that's kind of a high level view of how the market's proliferating. And if you go to the next slide, I think we're now getting to the defining of the edge, and I'm going to hand it over to Jason to sort of explain what we have accomplished and how we should be using this. Jason? Jason, are you there? Uh-oh. Jason, I see you. No audio. Brett?
Yep, I am. I'm sending him a quick message that his audio appears to be out.
Well, I thought Zoom should have ironed out all these things. Sorry, folks.
Yeah, it looks like he's not muted, so there's got to be something else going on. Could be his headphones or laptop.
Can you guys hear me now?
We can.
That's it. Okay, Jason.
Okay. Yeah, I don't know why it's not working. Yeah, I've been unmuted, but I don't know why it wasn't working through my earbuds. So, yeah. So thanks, Arpit. So, let me hide this. Okay. Yeah. So earlier this year, we as a community got deep into taxonomy. So one of the old jokes in the standards world is, how do you solve the standards problem? You come up with a new standard, and we also saw a lot of problems out there with edge definition in terms of there just being so many different taxonomies and what I would call loaded terms in terms of ambiguous, near and far, thin and thick, and so a lot of confusion across the board. So what we did is we came up with a new taxonomy as a community. And this builds off of the one that we had when we launched LF Edge a little over a year and a half ago. And the idea here was to break down the edge, which is really a continuum, and that's one of the first key concepts, is there's not a single edge. It's a spectrum of different locations for compute, and they're based on a variety of trade-offs. And so the taxonomy, we recommend you go check out the taxonomy white paper. It's available online. There's a link down below if you get these slides, but you really get into a lot more detail. But looking at the edge as a continuum and thinking about it in terms of hard technical trade-offs makes it a lot more clear what we're talking about in terms of how various different edge compute tools apply to various different use cases. So of course, we've got centralized data centers in the cloud. That's on the far right. And then on the far left, you've got highly constrained devices out in the physical world. And the closer you get to the physical world, the more you move to the left on this chart, the more custom, complex everything gets. You've got very custom form factors. You have, every device out in the world has got a different form factor. Car is a little bit different than a toaster and a lamp. On the right, very, very standardized, high scalability. In the end, there's tens of public clouds in the world that are going to really matter. On the left, there eventually will be trillions of devices out there in the physical world. So huge exponential growth as you go to the left. In a perfect world, we would centralize all services, in the back end. But of course, the whole point with edge is for reasons of latency and bandwidth and security, autonomy, privacy, et cetera. We're seeing this shift where of course, there's still going to be compute in the cloud, but we'll see more and more compute, at these various different edges. Two big buckets that we've defined is service provider edge and user edge. The difference between these buckets is that they're separated by the last mile network, whether it's cell or wire line or otherwise. Wide area network access to the right side to the service provider edge, local network on the user edge. And that's a really important delineator, because as much as we talk about latency, and latency is a big factor, and of course 5G is driving latency down even further. If you're latency critical in terms of your application, like bad things happen if the message doesn't get there at all times, especially in a deterministic fashion, you will always do that compute or any kind of control locally, on the user edge. If it's latency sensitive, where maybe it's video streaming, augmented reality, all kinds of new services that we're going to see around augmenting assisted driving, autonomous, etc. That we tend to want to centralize, at the service provider edge, because we can scale across many users. Service provider edge tends to be shared resources, owned by obviously service providers. User edges tend to be more owned by them, the end user, whether it could be an enterprise or a consumer. And there's not a hard line, and there's some divide, and we get into a lot more detail in the paper, but that's the main bucket. The next big trade-off that you see, so the on-prem data center edge, that's all that's on-prem traditional data centers we have in buildings. We micro-modular data centers next to your building. The key here is that from the on-prem data center edge all the way to the right, that's generally pretty consistent data center class infrastructure. There's some unique needs around regulatory and thermals and whatnot if you've got stuff distributed in different locations, but generally fairly consistent server class networking infrastructure. And we're seeing evolutions of tools like Kubernetes moving left and helping to comprehend distributed clusters and things like that. But again, generally the same tools. When you get to the left of the on-prem data center, now you're in what we call the smart device edge. And the reason we called that is, as Arpit said, there's, IoT is a workload within the broader edge spectrum. You can't forget about all those mobile devices out there, client compute, et cetera. So the smart device edge, as we defined it, is any compute outside of a physically secure data center that's still capable of running apps. So that includes, all the client devices that we've had for some time. Those are solved problems in terms of iOS and Android and Windows, big ecosystems around those foundations. But in the IoT sense, it's the Wild West. So we've got so much fragmentation around, whether it's a gateway or a hub, a router, a server, anything kind of distributed out in the field. And you'll see as we talk about the projects, there's a lot of LF Edge projects looking at how can we a lot of efforts. How can we make more consistency and interoperability at that component of the edge continuum? And then you go one more click to the left, and now you're in constrained devices. It's generally driven by memory, at about 256 megs of memory and below. You're now constrained enough to where everything has to be embedded. You can no longer do the abstractions for running containers or virtual machines. It's much more custom embedded software development, which adds a new layer of complexity. And we're seeing evolutions of tools there, and things will get easier over time. But each one of these buckets has an inherent trade-off. And so we've gotten a lot of traction on this white paper, a lot of interest, because it just breaks it down into those technical trade-offs, wide area network, local network, in a data center, not in a data center, able to run apps, not able to run apps. So again, recommend checking it out. And next slide, we'll kind of talk about how the projects fit across the spectrum. So this is that same taxonomy that we just talked about, and the projects that we have today within LF-Edge. Actually, secure device onboarding is not on this slide, but that's all about how do we drive zero-touch provisioning across devices in a scalable fashion, in the channel. ARPIT mentioned Akraino and EdgeX Foundry. So Akraino is spanning, it's more at the infrastructure layer. And while Akraino started with the more of a focus on the service provider edge, blueprints are being built kind of across the spectrum, when we expect there to be even more tying things together as you get closer to the user edge side and in the physical world. And EdgeX Foundry is focused on how do I make sense of all of the different protocols and fragmented hardware and whatnot within that IoT component of the smart device edge. EdgeX is built for maximum flexibility and being very, very modular. It's a cloud native approach with microservices and platform independent architecture. Fledge is a project that, on the surface, it looks like they're highly overlapped in purpose, but actually Fledge has made some different choices in terms of what types of devices they go after, what types of use cases. They're both data stacks for IoT workloads. How do I normalize protocols? How do I run analytics on top? But they're slightly different approaches. And of course, the whole point with LF-Edge is how do we start to drive more convergence in projects over time where appropriate, but also recognize that this is a continuum. And you can't have a one-size-fits-all across the board. HomeEdge is actually leveraging some of the different projects like an EdgeX that's focused on how do we build services around the home. More and more homes are going to have these server-based nodes within the home that drive different things like video surveillance and general AI workloads. So there's focus there. Beidou is a project started by Baidu that's looking at how can you develop services that are delivered from the cloud closer to the user for AI and the like. Open Horizon is a project that's new to LF-Edge that's around how do I distribute containers across the spectrum. And then Eve is a project that is really about how do I abstract that complexity for IoT edge compute from the hardware. So think of Eve, it's kind of looking to be a universal OS so that you can deploy any workload on top of edge hardware. Think of Eve as like doing at the smart device edge what Android did for mobile. So all of these projects, there's a lot more detail online, won't get into all of it, and you'll hear a little bit about the projects throughout the day, but each one of these projects are targeting a specific spot of the continuum, and the whole point, as ARPIT will summarize, is how do we harmonize this more over time? But most importantly is how do we make them work really well for end users, which is the whole point of launching this aspect of the community, so that we can make sure that the investment that we're making here maximizes use for end users. If you go to the next slide. And so So, I recommend you check out the Akraino blueprints. So there's a variety of blueprints today. We're on the release 3 within the community. We'll talk about a little of this today as we go through. But again, the idea is to create deployment-ready, tested blueprints that address various different elements across the spectrum. You can see that it was more focused on the service provider up front, but we're starting to see additional extensions to that user edge. Next slide. The point here, so LF Edge is not about reinventing things. We're actually trying to be as agnostic as possible around various different technology choices. There's a lot of great technologies out there. What we need as a community, for Edge, for IoT, for really a lot of different trends, 5G, et cetera, is to package up these technologies, collaborate across the board, both upstream and downstream, and create more consistent, interoperable foundations that people can leverage and then go focus on value. A big point of open source is to, that shared technology investment is to minimize undifferentiated heavy lifting that so many people have done in the past, and we're still seeing it, today. Is how do we work together to create a more common foundation? And the whole point here with getting feedback from end users is so that we can maximize that horizontal applicability while also recognizing there's inherent trade-offs. We're also collaborating with some of the various different consortiums out there, and it really is about working together across the board to make it easier to scale solutions for customers. Next slide. So you'll see if you go through the LF Edge site, get involved in any of the projects, a number of the use cases that we're already addressing are available in various different demos online. So each project has got sort of some initial focus areas. We're looking at expanding that out as we go. And you'll start to see more and more bleed between the projects. I mean, we're not trying to build vertically focused projects across the board. We want to build horizontal technologies that are highly applicable to a number of different verticals. And so while we've started in certain areas with these projects, again, the whole point here is to get that feedback so we can make them as flexible as possible across the board and then start to see more harmonization over time. Next slide. I think with that, I'm going to hand it off back to Arpit to talk a little bit about the growth in LF Edge over the course of since we've launched it.
Oh, thank you. Thank you, Jason. So, we are really excited about how LF Edge not only collaborates between the projects, but also across the networking community and the cloud community and various consortiums, whether it's IIC, ACC, etc. Okay, so with that said, we actually announced results of a survey that the members had. All the LF Edge members, you developers, and many more, and we have really been very pleased with the results, specifically because the fundamental question that inherently bothers pretty much the business decision makers is, why should I do open source? And the first answer 5 years ago was always, oh, it's free and it's cheap. And that's no longer the case. That's on the extreme right. Yes, it does drive cost down, but that cost is really an operational cost. As Jason said, right? It's really that undifferentiated software, right? And the interoperability that we are accelerating in the open source. But the three big things that have come out from the survey is, people want to, really focus on market creation, adoption, and acceleration, and collaboration. Those are the top three. That's what community-driven collaboration through foundations like LF Edge give you. And that's why, we are here to serve you, right? So that's kind of the high-level view of this community. If you go to the next slide, here's a snapshot of where we have come in the last couple of years. This was launched in 2018. Definitely a very steady member growth in terms of year over year. Projects have definitely been on the waiting list to get onto LF Edge as they realize that this is where the community is. Starting with State of the Edge that came in as kind of as a project that is, again, non-code, but really brings you the glossary, brings you the definition, brings you thought leadership, etc. Open Horizon SDO came in, as Jason pointed out, right? So good, steady project pipeline. Deployments and downloads have, which are kind of the true measure of adaptability or adoption, is really growing significantly. And then I think what we need to look at is, if you look at the two metrics that we value, one is the developer growth and commits, right? So are there people around the globe helping build the community, and are they contributing? And where are they contributing? So really all going up to the right as we would like it. And thank you all for doing it. Some of you are on the call. Some of you have actually presented, done demos, etc. So that's kind of the high level view of the community. Very exciting. For those of you on the call who have not joined LF Edge as a company, please do so. Contact us. It's very easy and it's a very vibrant community. So with that said, I think if you go to the community landscape page, if your company is not represented here, it's very easy. This is landscape.lfedge.org. You can put it in. It's a very standard way of showing progress and where you fit into the overall landscape. If you go to the next one, that would basically summarize the premium members and the projects. I think we talked about the 9 projects here. As you can see, there are various stages of growth and maturity in terms of the timeline and deliverables and things like that. A wide cross section of premium members. Again, if you go to the next slide, I think it will summarize the premium members quite well. This is the general members and the liaison one. But the reason this is going, this is fine. Go to the next one. The reason we are getting so much traction is our goal at LF Edge is to, harmonize and unify Edge in a horizontal manner. And that's across various markets: IoT, enterprise, cloud, and telecom, among others. But more importantly, we are keeping it open and interoperable, right? As a community, we need to be hardware independent. So you can see the likes of the ARM, Intel, Qualcomm, etc., all part of this community, premium membership. Silicon, right? Independent of all that. Independent of the cloud, you can see, Tencent and Baidu and a lot of the other players joining here. Independent of the OS, right? There is no one OS. It could be very strong RTOS all the way to a lightweight Linux, to any OS that can fit in the application, and clearly keeping the protocol independence, right? There's hundreds and 150 messaging protocols. We are not that interested in picking the winner, right? But the abstraction, the lifecycle management, that's what the team and community is focused on. And of course, we're going to take advantage of what's happening around us, right? In terms of telecom, cloud, and enterprise, right? For example, 5G, which gives you that latency and mobility to your edge application. Absolutely critical. And then, as Jason said, right, it's in collaboration with the consortiums, and it's similar to other communities like networking or CNCF. So that's kind of a quick summary of LF Edge for those of you who have not really participated. We're hoping to have you on board and have as many of your players as well. All right, so with that said, I think we can probably wrap here. Before we start, I think there were a few questions. Let me see if I can go back to the questions. Could you share the presentations? Yes, this session is being recorded and it will be posted. I think that was already answered. The next question was, how about ETSI MEC reference architecture alignment and collaboration with ETSI? So if you look at Akraino, and several of the MEC blueprints are there already, right? Which is very good news. If you take a higher level up, you should know that Linux Foundation, at the Linux Foundation level, not at LF Edge, but at the Linux Foundation level, has publicly collaborated and signed a press release last year. And that's given us the green light to collaborate with these organizations, specifically at ETSI MEC. All right, I think that's it, right? Did I miss any questions, Jill?
No, I think that's it.
All right, I think that's it. Jason, do you want to talk about
Yeah,
the Vertical Solutions Group now?
yeah, I'll talk about this real quick, and then we'll hand it off. We'll start with automotive, but yeah, definitely. First and foremost, we just encourage people to get involved. Anywhere within LFEdge that makes sense. The idea with these end user groups that we're launching, we've got this vertical solution focus group that we're bootstrapping. It's a very similar precedent to what is running today in Cloud Native Compute Foundation, also LF Networking. This is about getting more feedback from end users that are consuming the code from these projects. And the goal is, as I kind of touched on before, is how do we make sure that these projects, as they continue to evolve, provide maximum value for people developing solutions, regardless of market, whether it's industrial, enterprise, or consumer. Recognize that there's inherent technical trade-offs. It is a continuum, but also try to have as much commonality as possible across the board. And so these vertical solutions groups will output requirements back into the projects. We'll create demos that are specific to use cases, and you'll see some of that discussion happening today. White papers, other collateral. We'll build on the existing taxonomy white paper as we go and get even deeper into various different use cases. But the important point on the first round was, let's establish a common language in terms of a taxonomy to make it easier to have those discussions around very focused solutions on top. Next slide. So we've been bootstrapping this effort for vertical solutions groups. We've got 3 that are in flight today. Focused on manufacturing, retail, and kind of telco cloud, various different services for very specific use cases delivered up by telcos. That kind of brings up a point. An end user takes various forms. Of course, there's end users that are companies delivering services to their customers. Could be any number of different private companies, and then you've got service providers that are basically consuming code and delivering those services to end users. And so you've got various different stacks in the spectrum. And all is fair game. It's really looking at it as consumers of open source code to be able to go develop new solutions for a customer base or for end users. Very key point too is that across the board, LFEdge is an open community. Everything is done transparently. Meetings are open, recording shared, minutes. We welcome people to contribute, join not only these end user groups, but also various different elements of projects as well. There are benefits to being a member. In addition, you don't have to be a member to contribute to LFEdge, but there's benefits in terms of it. I mean, you saw in the survey results from ARPIT in terms of breaking through and developing new markets. It's almost like a vendor neutral partner program in terms of working with other industry leaders and building even business relationships on top of the work that we're doing in the open sense. So recommend consideration for membership, but of course it's a technical meritocracy in terms of the code side of things. Next slide. So other ways to get involved. So Brett mentioned that on the 20th, we're doing a second event like this. This one's a little bit more centered around Akraino, given the tie to a lot of the networking elements and the ONES focus. The next one will be more holistic across the various different projects. There's some registration information will be available soon. If you would like to lead a new group, if there's another vertical, there's just many different spaces. If you're an end user in any number of verticals where you see value in providing that guidance to the project, email info@lfedge.org. And all it takes, in addition to being willing to lead the project, is include one of the LFEdge projects as a seed. We always prefer to have multiple projects because we're trying to harmonize across them, but we do want to have it relevant to at least one of the core projects within the umbrella. And the other way to do it is just join the TAC. As mentioned, all meetings are open, and as progress updates around this thread, that you'll just continue to keep informed. Last slide. as I mentioned, regardless of where your interests lie, it's very easy to get involved in LF Edge. There's a couple details here. You can just go to lfedge.org and just dig in, dive into any one of the projects. The TAC does provide more of that kind of comprehensive view across the spectrum. Attend meetings. The best way to vote in open sources with your keyboard, of course, and writing code. So just feel free to dive in anywhere. But we would definitely welcome any feedback from end users on how we can maximize the potential for this, for all of us to just be able to focus on value creation throughout the spectrum. So with that, I think we're going to get kicked off with automotive as sort of the first focus area, both vertical and some of the use cases within it. So I'll hand it off there.
Thank you, Jason. Thank you, Arpit. And thanks for folks who have put questions into the Q&A window. For those that did recently join, we're leveraging the Q&A functionality. So as you have questions that do come up, feel free to ask and our panelists will be happy to answer. Up next, we have Zhuming Zheng from Jinghong with a automotive use case out of the Acreno project. I think it is a national holiday actually in China today. So, but Zhuming was gracious enough to prepare a small presentation for us. Aaron, if you can go ahead.
Dear members, I'm Zhang Zhuming from Xinhong Technology. I'm honored to have this opportunity to introduce some technologies and scenarios about autonomous driving. The presentation is the trend, key technologies, and the application scenarios of IVSS. Now I will introduce the first part. The first part is the current overview of connected cars. When the automotive industry is deeply integrated with the Internet of Things, communications, and other fields, people will realize the real-time interaction between smart cars and smart roads, and develop active vehicle control and rules based on the collection and integration of dynamic traffic information in all time and space. Collaborative management fully realizes the effective coordination of people, vehicles, and roads, and finally achieves the goal of improving traffic efficiency and ensuring traffic safety. This is the huge value hidden behind the vehicle-road coordination. Now, let's introduce the trend of software-defined cars. Automobile intelligence requires real-time processing of large amount of data from computer vision based on mountain sensor input. High-performance computing firstly needs the support of a new hardware architecture, and secondly, it also needs to rely on a new software architecture to support cross-platform computing and processing capabilities. High-performance microcontroller computing, distributed computing, and remote diagnosis. In the past, the automotive EEA has always followed the one function, one box distributed architecture model. In this form of automotive electrical and electrical architecture, every time a function is added, corresponding controllers and communication signals need to be added to further increase the system. The following two factors will reshape the future EEA. Then look at the new generation of EEA. The first is to support the system integration of software platforms. Although today's automotive EEA can be classified into different domains such as infotainment classes, chassis, and powertrain. The infotainment system usually use Linux or commercial general purpose operating system. AutoSHA Classic platform is the embedded ECU standard with strong real-time performance. With the increasing demand for computing power of new technologies and deep embedded system in the future. The third controller is urgently needed. Device domain controller is used to integrate the function node to form a domain centralized or cross-domain centralized EA. The second is the transition from signal-based to service-oriented communication. Traditional car communication is still signal-based. That is, the sender doesn't care who received it, but only sent to the signal, and the receiver doesn't care who it is. It is only responsible for receiving what you want. This method is very suitable for application scenarios with limited size control data. After advanced application scenarios such as autonomous driving are added, the dynamic interaction of large amounts of data must adopt a service-oriented communication method to improve communication efficiency and reduce load. In this method, the receiver as a client not need to find and subscribe to service and wait for it to be received. Information is enough, and the sender as a service provider only needs to provide services and information to subscribers. In the future, with the substantial growth of automotive electronic and software functions, it may eventually develop to centralized EA for vehicles based on a central computer, or even vehicle road cloud computing collaborative control. Now, under such a trend, a new software architecture platform that is highly flexible, high performance, and supports high performance computing clusters, dynamic communications, and other features is required. That is adaptive AutoSHA. Compared with the classic AutoSHA, although real-time requirements are reduced, but on the basis of ensuring a certain functional safety level, the support for high-performance processing capability is greatly improved to support the development of intelligence interconnected application functions. The emergence of adaptive AutoSHA is not to replace the classic AutoSHA platform, but to achieve coexistence and collaboration between the two for different application scenarios. The classic AutoSHA platform supports high security and high real-time application scenarios. Therefore, deep embedded software functions need to be deployed and run in classic on the platform. In short, adaptive AutoSHA EA realized the decoupling of software and hardware of the car, and will eventually promote the realization of software-defined car. At this application software level, the key technologies of autonomous driving can be divided into three parts: environmental perception, behavior, decision-making, path planning, and motion control. This picture is an example of an open autonomous driving framework. From left to right, the first step is collection and processing of environmental information and in-vehicle information, which is a basic and prerequisite for autonomous driving of intelligence vehicles. In the middle of prediction and decision, after obtaining the surrounding environment through sensor recognition, we must make full use of this information to understand and analyze and decide how to take the next step. To accomplish this task is the most powerful brain. In the past period of time, where the traditional OEMs, autonomous driving startups, or technology gains, they are basically based on intelligence. That is, all sensors are computing power units are mounted on vehicles. Due to the problem encountered by intelligent vehicle in height, countries' autonomous driving technology routes had begun to tail in the direction of vehicle-road coordination in the past 2 years. Now let's talk about the vehicle-to-road collaboration, V2X. V2X includes car-to-car, car-to-infrastructure, car-to-internet, and car-to-pedestrian. Through the vehicle-road collaboration, Smart Car opens up the external brain, provides rich, timely, and effective information input, reduces the complexity of decision-making, gives the vehicle a good view, and reduces the uncertainty of decision-making. Based on the request, we need to discuss the SOTIF. At present, the OEM are still in the earlier pre-research and technical research stage for the road-to-vehicle collaborative automatic driving technologies. When working with software, we found that not all security problems come from system errors and failures. In many cases, system security problems come from environmental impact and unexpected security problem. For the autonomous driving system, the system takes over the control of the vehicle, even if the system doesn't malfunction. The uncertainty of the black box output may cause the function to prevent and cause traffic injuries. The safety risk caused by the system function not meet expectations in such man-fault conditions is the problem to be solved by the expected functional safety SOTIF. Simply put, SOTIF focuses on avoiding unreasonable risks due to expected functional performance elimination. Because SOTIF was born in the context of the development of intelligent driving, if it is classified according to the foundational chain of intelligent driving, perception, decision, acquisition, functional performance limitation are reflected in these three aspects. Sensor limited lead to scene recognized errors, including missed recognition of driving misoperation. And the second is insufficient deep learning cause the decision algorithm to judge the scene incorrectly. And the third is diversion from the ideal target. And from another dimension, functional performance can be summarized into 4 categories. The first is intervene in dangerous situation, normal work. And the second is intervene in a non-hazardous scene, force trigger. And the third is do not intervene in dangerous scenes, miss trigger. And the last is normal shutdown. Now we can see it can be seen that there is no risk in the first and the first cases, and the second and the third cases are risky. Therefore, this force trigger and missed trigger are the categories that SOTIF need to be considered. To effectively avoid false triggers and missed triggers, the first step is to identify and classify the scenes and determine which scenes will trigger safety and which scene will not trigger safety. In SOTIF's methodology, all scenarios are divided into the following 4 parts. And the goal of SOTIF is to reduce area 2, no unsafe scenarios, and area 3, unknown unsafe scenarios, as much as possible. For area 2, no unsafe scenarios, the basic idea of SOTIF is to identify risk scenarios through safety analysis, develop countermeasures to risk scenarios. Build a real-time simulation environment for known scenarios or design real vehicle tests and optimize them based on experimental result design. For Area 3, it is relatively tricky to deal with. For example, this is like when we are developing a car that will be put on the market in the future, we need to identify in advance in various scenarios that a car may encounter under road controller conditions in the early stage of the development. I think even if the world's top security experts sit down and search the answer, the output will be difficult to satisfy. In order to let everyone feel how difficult this problem is, please see the following example. Tesla's smart driving function mistakenly identified the lucky right circle as a roadblock. How is SOLTIF applied in the development of fully autonomous driving? For the assisted driving function, the driver is in the loop and the automatic driving system provides reasonable assistance to the sure thing system, and the unsure thing is handed over to the driver to take over. So in theory, as long as we have enough test data and make sure that the thing is judged accurately, coupled with the driver's feedback to grasp the design direction, we can finally define a balance line clearly, so that the functional design can be not triggered and triggered to find the balance point. But if it is unmanned, the driver is not in the loop, and the system needs to make judgments in all scenarios, which requires very high system requirements. It is foreseeable that with the help of IVSS, the complexity of the automatic driving system can be greatly reduced. In fact, in the county autonomous driving application cases in specific scenarios, the information from the field side sensors can indeed effectively reduce the complexity of the automatic driving system. Next, please let me introduce the demonstration application and industry development trend. Whether it is autonomous driving or intelligent network vehicles, it should be said that there is still a long way to go in the choosing of autonomous driving under various working conditions and various conditions. For highly automated driving, it can be used in specific scenarios such as violent parking pods, factory parts, and other specific area and specific scenarios. It is still a competitive point for mass production of automobile. From the current development trends, there are two trends in the future of autonomous driving. The first is the addition of connected to autonomous driving. First, it must adapt to countries' infrastructure, including countries' roads infrastructure, information infrastructure, and countries' map positioning and communications. They are completely local. The second is that if the future automated driving is to be networked, there will be a networked operation platform, and there will be a country standard for network operation. Future automotive products and product architecture will change. At least the current EA will change. The EA of automobile has changed. Of course, it is a new standard vehicle. To truly promote autonomous driving in the future, product forms will change. There are 5 basic platforms in the product form, including cloud control basic platform, high precision dynamic mic based basic platform, vehicle terminal basic platform, computing basic platform, and information security basic platform. These 5 platforms are new parts and new key information, new important components for the new generation of automotive products. The key components of traditional automobiles are the engine, power system, drive system, control system, braking system, and driving system. In the future, there are 5 major technology platforms on the system. Now this is the end of my report. If you have any questions or interest, please contact me at email cuidea2966@2066.com. Thank you for listening.
Brett, I want to add one thing. Zooming, thank you for the very good insight. I also want to link this back to the work that's going on in Akraino from a blueprint perspective. So there's a connected vehicle blueprint that has been released in release 2 and has been updated in release 3. Again, it's kind of an open source edge with MEC with a V2X application that's run. I think it's been tested on bare metal containers and VMs. And from a network side of things, or from a connected vehicle side of things, the value that blueprint provides is obviously, more accurate location. I think it's 10x more accurate, really smarter navigation, safety improvements, right? So risk mitigation, etc., and traffic violations, right? So as you can see from these vertical groups, not only do the vertical industries, in this case automotive, that they're coming towards the network and towards open source, but the open source industries like LF Edge and foundations and projects, they're moving closer to the vertical. And let's be honest, a microservices app developer, Java person who has coded on a normal IT system has no clue what this presentation was about, and vice versa, right? So this is where this vertical solution group is really, really emphasizing to bridge that gap. So I just wanted to add that to sort of connect it back to LF Edge and how things are working here. So over to you, Brett.
Perfect. Thank you again, Zhiming and Arpit. Up next, we have Sriram with Arna Networks presenting a use case on manufacturing and industrial. Sriram.
Hi, everyone. Is my audio okay?
Yes, we can hear you.
All right, great. Hi, everyone. Morning, good afternoon, good evening. I'm Sriram from Arna Networks. So in this presentation, I'm going to talk about the use case of manufacturing industrial in particular, and how 5G Edge and some of the LF projects facilitate that. Right. So the first part of the presentation is about how 5G enables the Industry 4.0. So, as you all know, the 5G technology, there are 3 sort of major components, right? So the ultra reliable low latency communication, the massive machine type communication, and the network slicing, right? So all 3 of them we believe are very relevant for the Industry 4.0 applications, right? So because some of them are pretty obvious, you need a very low latency communication for some of the industrial applications like manufacturing and so on. And similarly, the massive machine type communications, because there are going to be a lot of these devices that need to communicate. So it makes a lot of sense to have a technology that supports that. And the third one is network slicing, right, which is a very important feature in 5G, which is very useful in the industrial applications, where you may have different types of applications with the different characteristics or different requirements. Right? So, and that's exactly what the network slicing will enable you to do. You can create multiple slices, one slice with low latency, the other with high bandwidth, and then they can all be supported on the same shop floor seamlessly with 5G technology. So these are the technologies that enable Industry 4.0. Yeah, if you can go to the next slide. All right. So now, what are the requirements for the Industry 4.0, right? In terms of the 5G edge capabilities, and why some of them cannot be done with some of the existing technologies. Right? Obviously, people have been doing them, right? So why can't they be done with existing technologies, right? So these are the 4 categories that we believe are four requirements which are required for the Industry 4.0. And I'll also talk about why they cannot be done with some of the existing technologies. Right? So the first thing is reliable connectivity, which is obviously a requirement in the industrial environment. So Ethernet can be used, but it's expensive, and being wired, it's hard to maintain. Right? And the Wi-Fi is the other option, which can be used, but again, it doesn't provide the kind of reliability, the low latency, and the support for the different types of edge applications that are required. And lastly, the important thing, the device management, right? So for this reason, we believe, these technologies may not be suitable for this next generation of these industrial applications. And of course, they can be used. It's not that nobody will use them. It's just that 5G makes it a lot easier, 5G edge capabilities. The second category is the edge IoT frameworks. Right? So there are some existing frameworks. For example, the AWS has a Greengrass, Amazon has Azure IoT Edge, EdgeX Foundry. So they need to communicate and manage these devices. So that will require some, these technologies to be supported on these frameworks. So that will that's another reason why the 5G edge makes sense in this in this domain. The third is obviously the edge AI and ML. So which is again another major driver, right? So a lot of the applications can be thought about in the industrial domain, where the AI ML can provide inputs for the quality assurance, machine analytics, surveillance, and many more. Right? So this is not an extensive list. So these algorithms may be very dynamic. So it makes sense to have a framework or a technology that supports these technologies, edge AML very seamlessly. So that's a third requirement. And the fourth one is the applications, right? So the edge can provide lots of arbitrary applications which are cloud native. Right? So obviously applications are there, the existing applications are there, but these cloud native applications which are built ground up as cloud native, such as augmented reality, proactive maintenance, drone control, the vehicle control that the previous presentation talked about for autonomous vehicles. So all of these applications, again, will require cloud native nature. And so these are the capabilities that 5G and edge can provide, which are required for these industrial 4.0 applications. So essentially what this tries to convey is that 5G edge is the most suitable technology for this domain, for this use case. Yeah, if you can go to the next slide. All right, so in this particular presentation, I'm going to focus on the application management problem, right? So obviously the industry 4.0 has many problems, and there are many solutions. Some of them could be using the other LF projects, but what I'm going to focus in this presentation is the application management problem. Right? Now, what are the requirements for the application management in the industry 4.0? Right? And why how they can be satisfied with some of the existing projects. So that's how I'm going to present this. Right. So the first requirement is a reliable 5G management in all my factories. Right. So that's kind of a basic requirement. So there should be a zero-touch provisioning. Right. So a lot of factories, may not even have the accessibility for people to go and provision things. So pretty much a zero-touch provisioning is a requirement. Network slicing that I talked about in the earlier slides. Right? So there's a requirement to have different types of applications having different characteristics, which exactly is what the slicing will solve. Right? And the ongoing optimizations. You may want to keep optimizing things for better efficiencies in the factories. And the last thing, and last kind of sub item in this is the automatic corrective action, like the service assurance. For example, based on certain inputs, you may want to take some corrective actions in an automatic way without any manual intervention. Right? So these are pretty much the requirements for any industrial applications to solve in terms of the application management. So that's the first category. The second category is, how do I manage my applications, right? So let's say I've deployed my applications. Now that's not enough, right? So once I do the initial orchestration, I have to keep configuring them. I have to keep managing them. I have to do the lifecycle management, right? And I have to upgrade some of the software. So all of these lifecycle management items, scale up, scale out, all of that, right? And service assurance, and the termination upon completion. So these are the things that are required to manage my applications on an ongoing basis. The third one is the need to be fully automated with one click. Right? Now, this can be done with the existing ad hoc scripts, homegrown applications. So these are all problems that are solved already, right? But the point here is that when you go to, you're okay with tens of such applications, right? When you go to hundreds or thousands of these in multiple factories, right? With different types of applications, each of them having their own way of managing things, their own way of, vendor tools. So you can imagine the kind of, complexity that gets involved in this. Right? So you need a fully automated way where with a one click, you can configure whole bunch of these devices with certain set of parameters, and being able to scale. When you start these new applications or expand to new factories, you want to be able to scale it. So these are the application management problems. Obviously these are the problems in in most of the domains, but in an industrial domain, these are clearly some things that need to be solved by the operations manager in the factory. So this is all sort of building a case for how 5G Edge can be is an ideal solution for this problem. If you can go to the next slide. All right. So this is one of the solutions. Obviously it's not the only solution. So I'm going to talk about some of the technologies that we leverage for this, especially in the context of the LFN Edge projects. The requirements is that it has to be lightweight, cloud native. The CI/CD release process is pretty much a requirement in this domain. They have to be vendor agnostic. That's the reason why people choose open source technologies, where the CNFs and the Kubernetes providers can be vendor agnostic. The access technology, again, in this presentation, we're going to talk about mostly about 5G, but it can also be used for LTE, Wi-Fi, maybe if the need be. Support for the Kubernetes, NFVA clouds, and then the projects that are used for the open source projects that are used from LFN, mostly for the ONAP project. And that's what I'm going to focus on this presentation, which are applicable for this for this solution. If you can go to the next slide. Yeah, so these are some of the details. And again, this is more generic. It's not specific to the industrial applications. But again, all these requirements are pretty much needed for, for this domain. Where you need to have the cluster registration because you need to have, there may be need for multiple clusters that need to register. Distributed application scheduler because your applications may be scheduled on multiple clusters in the factories where you need to be able to schedule them, based on the intents. You may say that certain applications have certain requirements and they need to be placed in certain types of, these clusters. So these are the requirements that are that are clearly there for the industrial applications. And the third thing is the platform awareness. So certain clusters may support certain hardware features, and that's clearly something that may be prevalent in the industrial applications, where there are certain specialized clusters with certain capabilities where certain applications can run. And obviously, nobody's going to decide that manually where this should run. Right. So all of this should be built into the software. Distributed cloud manager, which can present a single view. For example, you have multiple factories and the clouds that are distributed, and the ability to manage them as a single logical cloud across them. The mesh controllers, the secure WAN controllers, and monitoring. So again, these are all the features that are required for these 5G Edge solutions, which are clearly a requirement for the industrial applications, even though they are more generic and may be applicable for the other verticals as well. Yeah, you can go to the next slide. All right, so now I'm going to talk about a couple of proof of concept projects that are going on in the community. So these are all in the sort of under the using the open source initiatives from the LFN projects. In the next few slides, I'll talk about the specific projects that are used and the companies that are involved in this. So the first POC is a private LTE 5G with MEC. So this is under the Akraino blueprint, one of the Akraino blueprints. That's in progress right now. It's not complete yet. So essentially, what we're trying to do here is to build an end-to-end solution with 5G. Can also be with private LTE, but and then move into 5G. So where we are creating 2 or more edges and a core, with all of them running Kubernetes and running different 5G applications. So some of them are CNFs, some of them are CNAs, but they're all cloud native applications, which are orchestrated using ONAP for KDS, which is a orchestrator that's part of the ONAP project. In the multi-cloud project. So that's the one that we are leveraging to orchestrate these container functions. And the goal of the POC is to show an end-to-end communication and accessing the data networks using these end devices. And again, like I said, this is not complete yet. It's still in progress. So we have a bunch of companies that are part of this blueprint that are working on it. And you can see the names here, and there's a Akraino page that has a lot more details on the current state of affairs, what we are using and what technologies are being used, and so on. And those interested, obviously can be part of this. So now I'll talk about the other POC. If you can go to the next slide. All right, so this is the second POC, which is actually in a much more advanced stage in terms of the capabilities. This was a part of this was actually shown in the keynote as well, and there's a demo booth where this is being demonstrated. So essentially, what we are doing here is that so we have two locations. The one is the UNH lab, where we have the NFVI hardware, which is the HP servers, and we have open source Kubernetes that's running on that, and that's the cloud that's used for it. And the ONAP for KDS is run on that, and that's the one that's orchestrating all these CNFs. And this SD-WAN is from Tonium is connecting that with another cloud, which is running in a Montreal lab. And there also, it's NFVI hardware has a bunch of servers and switches. And so there, instead of running the open source Kubernetes, we're running the Red Hat's OpenShift version of the Kubernetes. And that's where we have instantiated a bunch of these network functions from A10, from Altron. So essentially using the ONAP for KDS, so we orchestrate these services. And again, those interested, the demo recording is available. They can take a look at it. So this uses Altron's 5G core and the GNB emulator from Altron, and also another company called Rebecca. So these are the ones that we have demonstrated the interoperability of this. And again, the open source management that's used for this is the ONAP for KDS, which is part of the ONAP umbrella. So this is the second POC so we still want to keep adding more capabilities to this. So this is still a work in progress, even though we've made a lot of progress. So we want to show the end-to-end with a real radio and so on. So that's in progress. So right now we're showing it with emulators, but eventually we want to show it with a real hardware and with network slicing. So that's the end goal of this, which is in progress. And again, a lot of companies are involved in this. Obviously Red Hat, OpenShift, A10, Altron, Rebecca, Arnav. We are involved as ONAP for KDS. So these are the companies that are part of this initiative. Yeah, if you can go to the next slide, please. All right, so I think these are the technology partners in this POC. I mentioned some of them already. So some of them are already part of the POC. The others are in various stages of bringing their software to this. Obviously the cloud platform is the Kubernetes, open source Kubernetes or Red Hat OpenShift, and the ONAP for KDS is the other component. The other configuration piece that we're going to use for lifecycle management is a project called CDS again in ONAP. That's another open source project which facilitates the lifecycle management of the CNFs or CNAs. So that's the one that's still in work in progress. So we haven't started the configuration part yet. So what we have demonstrated so far is the orchestration, where you can bring up all these CNFs on these clouds. But the actual configuration and the service assurance using closed loops and using the network slicing is something that we are working towards. So that's where things are with this project at the moment. All right, I think that's probably the last slide, I think.
Perfect.
Yep.
So, folks, if you have questions for Sriram, I do see contact information on this slide, but while we have him here, please leverage the Q&A window. think it's either your lower toolbar or for some browsers might be upper. And if you're unable to find the Q&A box, if you can find the chat box, we'll take questions that way as well. All right. Not seeing anything come across, but we do have the contact information here. Should there be any questions that come up later. And I think with that, thank you again, Sriram. Up next, we have Yanjun Chen from China Mobile with a telco use case. Aaron, if you can click ahead.
Hello, everyone. My name is Yanjun Chen. I'm from China Mobile Research Institute. Thanks for attending this session. And today, I will give some sharings on the progress made by China Mobile on edge computing, including edge computing strategy, the technical focus, as well as the vertical solution development roadmap. Okay, let's start. As one of the telcos who has launched commercial 5G network services, China Mobile has announced 5G plus AICDE development strategy, which AICDE means artificial intelligence, IoT, cloud computing, big data, edge computing. And while the E represents the edge computing, it's one of the key capabilities of 5G network. And thanks to 5G core network design on flexible placement of the user plan functions, UPF. So with the user plan closer to end users, it meets the requirements on low latency, high bandwidth, data security, and high quality of service network for both 2B and 2C service customers. In addition, not only the network services, China Mobile also provides the cloud services to both individual and enterprises customers. And we will offer these cloud services at edge side, but more adapted to the edge side. So the strategy is to provide the network, edge, and cloud one-stop solutions to our customers. To go to a little bit more details, for 5G network services, China Mobile have the following technical focus to provide the high quality of network services to enable edge computing. So first is the edge traffic offload service, which will be enabled by techniques like network slicing, DN configuration, or uplink classifier in routing policy. Another technical focus is to provide the network features by open APIs. Network capabilities such as access control, the bandwidth control, and radio network information services, etc. In addition, 5G SA standalone private networking solution is offered to enterprise customers for high-quality network requirements. On the other hand, regarding the edge computing cloud services, China Mobile has provided the full-stack cloud services for customers. For the edge infrastructure, it will be benefit from the IDC resources owned by telcos like us, while in those IDC data center, both virtualized infrastructure such as the virtual machine or Docker container resources, or bare metal infrastructure could be offered to our customer. In addition, the hardware capabilities should be customizable according to different solution needs. And if we go to the upper layer, in PaaS layer, and China Mobile has announced the new edge computing PaaS platform named Sigma. For Sigma platform, it will offer groups of capabilities to end users, including like network capabilities such as location services, bandwidth management service, and UE access control service. Those are core features enabled by telco service players from telco networks capabilities. And also in this PaaS platform, general functions such as database, DNS configuration, or message brokers are common features for majority of applications. And for vertical capabilities, China Mobile now is actively working with vertical solution partners on vertical capabilities such as video analytics and artificial intelligence capabilities like NLP. So all those capabilities will be exposed by API gateway, and also this API gateway will be responsible for the capabilities registration, deregistration, and handle the load balance, user authentication, etc. In the SaaS layer, it includes variety of edge computing service applications such as Internet of Vehicle, AR, VR, cloud gaming, etc. And China Mobile is mainly working with partners together to offer end-to-end solutions. If we see the whole framework, we can see that edge computing is a full-stack technical framework from network deployment to platform setup to service enablement, service development. It's a very complex and long-term process. So regarding the key process made by China Mobile on edge computing commercialization, there are 4 summarizes in both network side and platform service side. First, since UPF, user plane function traffic offloading, is the very important first hop for edge computing in 5G network. So China Mobile has announced the Open UPF white paper and proposed to open M4 interface to decouple it from 5G core network. So this proposal will allow telco players to have more flexibility on UPF solution, as well as the UPF integrating with platform solutions to avoid the vendor lock. So this is the first progress made by China Mobile. And second, we're working with hardware companies to customize on general servers for adapting different edge data center environment. So those redesigned edge hardwares are commercialized, and we have purchased some of them. Third, China Mobile has announced the edge computing PaaS platform Sigma, as I mentioned in the last slide. While in this platform, telco featured capabilities are exposed by API gateway, and service trials have been made to test and verify this platform with real use cases, such as we have used Sigma platform to control auto-guide vehicles in a smart factory to improve the traditional solutions. And Sigma platform is also verified in the case of processing on edge side video camera streaming for product quality auto inspection in smart factory. In addition, China Mobile is also active in many open source communities to embrace the open source ecosystem and share visions with industries. And we propose to work together with ecosystem partners on solving some key and common technical issues on edge computing, finding potential edge computing use cases, etc. So those are the 4 key technological progress made by China Mobile on edge computing topic. Regarding the last point, open source community participation, the participation in Linux Foundation Edge project ECRINO is one of the key activities in open source community related with edge computing. Currently, ECRINO has released the R3 version and in a stage of planning R4 release. And China Mobile are leading 2 blueprints in R3 version. In the blueprint of cloud gaming, an ARM-based solution are investigated to provide the Android application solutions at edge side. And another one is SmartNIC blueprint. It demonstrates the 5G UPF can use this SmartNIC to accelerate the performance. Just recently, we have joined the technical steering committee of ECRINO 2020 to 2021, and China Mobile will continue actively participate and contribute to this open source project, to this open source community. In addition, to promote the industry development and to accelerate the maturity of edge computing ecosystem, China Mobile has launched over 100 service trials in over 12 provinces in China. Those service trials cover the main application categories including smart energy, healthcare, education, government, smart traffic, smart manufacturers, etc. And those service trials are the real use cases from our customers in different vertical areas. Through these service trials, China Mobile has got the best practice on network deployment, deeper understanding on customers' requirements in different vertical areas. And we get to know the end-to-end performance and if there are some open issues, etc. So those service trials are still ongoing and will continue extending to more use cases in more locations. So this page, it shows a service trial example we did together with another game solution partner in Sichuan province in China. In this service trial, delay tolerance is very sensitive, especially for the case when there's a game event. While at that time, many users will connect to the server together for real-time competing. And for big game event, normally hosted in the university, the delay tolerance is around 25 milliseconds. So in this use case, we have deployed 5G standalone core network to guarantee the normal game user experience. In addition, to guarantee the user experience of game event users, the UPF has been deployed in Chengdu City, which is in the capital of Sichuan province, so that the game event users can directly send requests and get response from the game servers deployed together with this UPF located in Sichuan, located in Chengdu. So it is more closer to user side. So the delay is very small. So this is one of the typical use cases we have trialed on edge computing. In addition, China Mobile also made the new practice on edge computing business incubation. Partners can make full use of China Mobile's 5G network as well as the cloud services to implement the service applications. and verify the end-to-end solutions and evaluate the performance, etc. So we will continuously welcome new partners join this incubation plan, and let's make effort together to accelerate the industrial development on edge computing and promote the ecosystem maturity in multiple ways. Okay, that's all that I prepared today. Thank you.
Yeah. Hi, this is Tina Zhou, the Equino TSC chair. So Brad asked me to say something about the China Mobile deployment has been already developed in Equino. So yeah, for the previous slide, Yanjing has already shown they have already been leading the IEC Type 3 and 5, the Android Cloud Gaming, and also the SmartNIC Blueprint. They have been participating in the 5G Mac and public cloud edge, and also Alt Edge, and also the Elite Blueprint. So thank you for China Mobile's contribution. This is really useful and leading the industry, especially the telco areas, to move to the deployment. And also, they are now proposing a new blueprint or blueprint family, which is called something like blockchain-based edge computing, because they already have some proof of concept already building. So I see China Mobile sets up a very good example how to have the closed loop between project production and profit, as Alpha Edge advocates. All right, I will stop at that. Thank you for your attention and participants. Any questions? I'm here to answer live or type the answers.
Hey, Tina. And Yanjun, we actually have a couple of questions. So why don't we address those before we move on?
Sure.
So the first one is, could you explain a little bit more about the answer of the first question, please? This was from Cristobal.
For the satellite?
Yes, exactly, about satellites and contributing to 5G.
Yeah, because it's not, well, there's no directly satellite discussion in Equino. However, I was the satellite representative from study group 11 ITUT. It's always like a supplement to the 5G, 4G, 3G at that time, the cellular networks, cellular technologies. So they don't like coexist at the same time. However, for some rural area, you probably heard Facebook's leading activity initiative called Magma. It takes care of this other non-cellular connectivities, which could be supplemented when there is no normal 5G, 4G LTE signals in some rural areas and countries and regions.
Great, thank you. We do have one other question. How is 5G multi-homing being interpreted in the cloud when multiple physical paths will have different latencies before being combined back into a single data flow? Is there a cross-layering technique between the MAC, PHY, and the upper network layers?
Yeah, so the 5G multi-homing is always a very interesting topic. We've already seen we like in the public cloud edge interface blueprint family, we got Microsoft, Equinix, AT&T, China Mobile, China Unicom. They were there discussing the multi-cloud and also the multi-tenancy and multi-homing issues, questions there. You're welcome to join. When the multiple physical paths there, yes, there may be having the different latencies before it's combined back into a single data flow. I think it takes the, I would say in the mass is the combined set, the longest latency plays there. This is the current the status quo of the industry. However, we see the telcos and the vendors, they're trying to fix this issue to see whether the latency could be in the median value of the different latencies. You also asked whether there's a cross-layering techniques. Yes, we do see the MicroFi and optical cross-layer synergy, the technology developed in both IETF and ITU study group 15. And once this technology all built up, Equinel is happy to integrate them into the 5G MAC and the ICN and the IEC and the PCI public cloud edge interface blueprint families. I hope it answers some of your questions.
Great, thank you.
All right. Well, thank you again to Yanjun and Tina, and as well as the questions over the window. Up next, Aaron, I'm sorry, if you don't mind advancing. There we go. We have a use case on transportation and logistics. We have Eric and Naeem joining us from IBM. And before they move into their presentation, we actually have a short YouTube video to play for the audience. So we'll see how well the internet treats the video play. And Aaron, I just dropped it over the chat. Sorry. I think an error, Aaron, I think you need to share the video screen. There we go. We had the presentation. All right, thanks, Aaron. We are going to stop sharing your video so that Eric, I believe you should be able to take over.
Yeah, can you hear me okay?
Yes.
Yes.
Okay, I'm trying to share my screen.
Perfect.
Are you seeing something?
We are at your title slide.
Okay, great. So you've just seen a little video, and we're going to go into the inside of that very interesting edge. And I'd like to start by saying that, so I work in IBM, and I have with me a very smart guy called Naeem. Naeem, a word on you?
Yes, hello everyone.
Okay, so How much time do we have? 15 minutes?
We're actually ahead of schedule, so you can go a little bit over if you need.
Okay, so we're gonna go short, but we have a lot to share if you're ready for it. So, and I will start. So hopefully the chart will move when I click. Yes, so this is the ship we're talking about. So it's a ship that's gonna commemorate the Mayflower crossing. The anniversary was 16th of September, and it got delayed because of COVID, but it will cross in springtime. The first mission is then to cross the Atlantic and also to carry science experiment. You can see on the drawing on the bottom right, it's very slim, low on water, powered by solar batteries. There is obviously a backup generator or ship, so it has no sails. Okay, it's propelled by a propeller. And it has absolutely no place for human beings on board, so no cabin, no deck. And it's also a technology proof for a totally autonomous, no man on the loop. So this is not a ROV type vehicle. And this is a very interesting edge. It's a very complex edge. And you will see it's also hybrid in terms of cloud configuration. And so I guess you should be interested. You'll find a lot of video about it if you search. It's made by a company in the UK and in the US called Submergence in the US and Sub in the UK. Those guys have been doing submarines for 20 years. They know all the technology. They know all the robotics. And the problem was to remove the man from the loop and bring the intelligence. So it was, even for them, quite a change on the fact that they were also going to go on the surface instead of staying under surface. So it is not a really easy task to do this because the marine environment is very highly regulated. So some of you may be seamen, but IMO is the acronym for International Maritime Organization, and they issue COREG, SOLAS, to say how you should navigate. So keep in mind that we have ships on the planet since a lot of years, and we're talking, tens of thousands of years, people being on some kind of boats. So a lot of regulation were created among the sanctuaries to define how you navigate, and you have to make sure that you follow those rules. It doesn't mean that everybody follows the rules, because the ultimate rule is always don't eat anything. So we're not talking about a car. There's no street, but we're talking about a place where people may do strange things. People may not signal where they are. So it's at the same time regulated and an interesting space. Then if you have anything and you are a no man on loop animal, a boat in that case, you have to be able to explain totally your decisions. So this is actually something that is part of the basic requirement. Anything that ship does has to be explainable from A to Z in case the legal authorities require it. Then it has to be highly secure. We're talking about one ship, but this is kind of a new kind of ship, and there will be many. So you don't want anybody to hack into the ship, take ownership of it. So for the Mayflower, knowing that ship is going to navigate about at 10 knots, there is highly a big risk if somebody tries to take it, because it's not a dangerous movement. But if you think into a larger ship, then you can have a very interesting security issues, and they wanted to address them from the beginning. And then, there was a lot of discussion in the previous presentation about bandwidth, latency, etc. So it's a challenge to manage and to send mission order to a ship like this. It's at sea. It is not always connected. It cannot be always connected. If there is connectivity, the bandwidth is absolutely miserable. Nevertheless, the latency is okay. I mean, we're talking about satellite transmission latency most of the time. So there is an interesting management issue on such a ship. So this is just to give you what are the challenges that were to be addressed on that ship. And I think I'm going really, really, very fast. So Naim, Let's
Yes.
explain the edge. That's your turn.
Thank you. Thanks, Eric. Hi, everyone.
Take
So
your
like,
timeline. I went way too fast.
so like Eric was explaining, and that's what, edge computing is about, right? All the challenges we have with the network latency and the connections, right? Dropping in between and with your far remote locations, low bandwidth. So in this use case where our edge is this autonomous boat, it's a Mayflower ship, right? That's our edge. And then you can see this is a logical diagram, and then we'll go into more into the technical depths of how this is all working. But if you look on the left side, right, that's the boat, the Mayflower, and it has the navigation system, many different scientific instruments on top of it. Then it has the telecommunication gear, so you can talk through the from the Wi-Fi when it's close to the port, or you can go through the satellite network or through the mobile modem. So all these different options are available. And you can see the connections going back, the sort of the solution we said, the IBM, the hybrid cloud option, right? So in the cloud, we have the solution, basically the backend components running, and of course the front end as well. So the data which is coming over from the board into the cloud, and then we have different kinds of microservices running on the OpenShift platform to normalize that data, do different kinds of analysis on that data. We have different kinds of feeds which can go to portal or this 3D visualizations, or we have the chatbot or different scientific teams, STEM purposes, school, because one of the purpose of this mission was to make data available freely for everyone, right? Especially for the STEM purposes, researchers, academia, and all that. Then we have further integrations. We have integrations with the AIS system. So we see where the boat is. We have integrations with the weather API. So and all of these different informations coming into, some of being evaluated at the edge, and some of being evaluated in the central location for further analysis. Then they have a control center as well, as shown in the middle of the picture, where all the mission management, vessel monitoring is happening. They have a safety care kill switch. I think that's required by the laws, and then different kinds of optimizations happening. So in a nutshell, this is like the high level logical overview. And Eric, let's go to the next slide and let's drill into
just one comment. I forgot to tell you earlier, but this ship is actually had its own homologation. So it's a real ship, not an experimental one. It's insured by a regular ship insurance. So this is not a toy, okay? Or test. It's going to sail for 10 years.
And I think you saw the video and the pictures in the beginning, right? So yes, and there's plenty of material available on the web on YouTube about this. Okay, so let's look at the solution architecture details. By the way, this framework, we are going to actually call this like an autonomous vessel framework. So edge computing framework for the autonomous vessels of the future. So we are working on that already. But let's look deep into this. So on the left side is our Mayflower ship. That's the edge, and it has a bunch of systems running on top of it. It has the NVIDIA, the microprocessors over there, and it has the Kafka. That's the messaging bus which is used to interact with different sensors information coming from different components, the telemetry data. And now from there are multiple paths to forward that information. So this is just about the telemetry data we're talking about here, and then I'll go into the edge agent as well. So we have, like Eric was mentioning, we have the connections through the over the internet, right? Whenever it's possible. We have another pipe through the satellite for the AIS data for the positioning, and it also provides various different kinds of metrics, like the speed in knots and the wind speed and different conditions around it. And then we have another weather API. So we know based on the position from which we get from AIS, what are the conditions or forecast for the journey of this boat. So all of that information comes into the IBM Cloud, which runs on OpenShift platform. At the bottom, you can see that we have, these are all cloud native, modern cloud native architecture based solution. So we have a bunch of different microservices which are handling different tasks. So we get all this information, whether it's coming through Kafka, messaging into our system, into our platform through AIS, through Weather Channel, where all of this information is stored in a MongoDB, another cloud native service in our cloud. And then we use a serverless mode, the functions, to route this data and do different things with the data. So the first thing is we as the data will be continuously coming, we take a dump into the object storage. That's for the historical and archive purposes. And where this is where all the STEM universities, academia, whoever wants to download, they will be getting information through the object storage. Then we have APIs available, REST APIs, and that's you can see through functions in the middle. You can call our API and get information in real time or on the historical stuff. Then the another interesting thing, if you go on our website, themass400.com, you will see this RT 7-leg octopus. That's basically the digital assistant based on the Watson assistant. We also call it the AI captain. So you can interact basically in simple word, it's a chatbot, but it has a lot of interesting things built into that into this bot. So that's another venue for the users to interact. Then comes the EdgePoint, the Edge Application Manager. That's IBM's Edge Endpoint solution. So basically, the models, like we talked about, there's a lot of AI stuff running on the edge, which is the ship here. So if you want to, pull the models, and if there is any updated model built in the central location, and the bot needs to pull any update, that's where the Edge agent can pull from the Edge Application Manager whenever there is a connectivity available. So that's the function of the Edge Manager. It's watching the board, it's sending the code. Basically, it's a pull from the board to the central location. Then this is running in a typical cloud infrastructure where you have the firewalls, DDoS prevention, all those things. And last but not least, we have the portal available, mass400.com. So if you go on the portal, you will see majority of the stuff, the data which is flowing through here. There's a link there that says dashboard, and maybe Eric can show us later. So you can click on that link and it will have all the telemetry, all the information there. And this is all work in progress, as the launch is in the spring next year. So we will keep on enhancing and adding more context into the portal and the type of data we are collecting and different kinds of collaboration we are doing in terms of different scientific projects. Okay, next slide. All right, so decisions. So of course, autonomous has to make lots of decisions. A lot of visual training has been done onto the models to detect the objects, right? So the easy ones are, you can see, try to determine, is this image an iceberg or a fishing ship, different kinds of categories of vessels, because I believe they have different kinds of protocols depending upon what kind of marine traffic they engage with. Then it's always checking, the direction where it's supposed to be, and also optimizing the routes. And the technologies behind, different kinds of like iLog, CPLEX, which is the decision optimization frameworks we use building models. Then we're also optimizing in terms of the resources on the board, right? So, the batteries, the solar power, so making sure that everything is in check. And then looking based on the weather. Weather plays a huge role over here. So based on the weather, we are, constantly optimizing the route. So these are some of the decisions. There are, of course, much more than that, but these are just some of the very high level, examples of decision making happening at the board level.
All right. So, because, there is always a lot of discussion about, okay, what's in the edge. So we thought about showing you what's actually inside the edge for doing the navigation decision. So I'm sorry for a bit busy chart, but it's actually highly simplified. So I would just explain you how this works from left to right. So essentially you have all the sensors on the ship, and I'm not showing everything. I just took the big ones: the vision, the radar, the local weather, and the AIS. There are a bit more sensors on that ship, like a sonar and LIDAR and infrared, but they're not useful in the explanation. So essentially you have a block of software which is in charge of making sure all the unstructured data becomes structured. So the best example is the vision. And to give you an idea of what it means, they've been collecting sea images from real, sea points on boats for 4 years to be able to have the right models. Those are not the models that you will see in a car. The boat is a permanently moving animal. The waves can be very high. So you can imagine that there is a bunch of things that are quite special into making sure you can recognize any kind of floating object. So that's the first piece. Then once you've done all that, you enter something that was on one of the charts shown by our friend from China Telecom about the data fusion. But essentially at that point, you're going to run a set of engine rules engines to check what you should do based on the regulations. So what are the rules at sea allowing you to do? And you're going to have to assess your position, you versus any object around you. So it's a one-to-one set of assessments that are going to give you what are the possible choices. And at that point, you have to take into account the maps, because some of the things you will want to assess are going to be the position of the coast, because you may want to avoid hitting the coast. And when you've done that and you have your set of possibilities, actually that's getting into some interesting math, because you will have to run in the ship. So this is again happening at the edge, linear programming programs to actually find the optimal route based on the weather data, and also based on you versus all the other objects around you. So you probably understand that one boat solution is very easy. A one-to-many solution is an exponentially complex problem. So you have quite a bit of linear programming utilized in the ship. They actually use a banking software for doing this, and it's very efficient. And once you've done that, you reach the rightmost box where you can compare to your mission. Is this aligned with your mission, and possibly with something new coming in that could be like an SOS or a request. And then you're gonna act, and you're gonna go on, act on the rudder and act on the propeller speed. And so that's kind of all the stack you have in there. So again, this is this was on the previous chart. This is all Linux Docker containers. And when there is a connection, you may receive new mission information, or you may want to send all your decision taken to the ground through the intermittent connection that's typically satellite at sea. And on the right side, which is the the on-site at the plant, this is where all the development is made, and this is where they can trigger updates and based on the data they receive from the ship. So that gives you like a very simplified idea on the way the system works. And I'm sure you understand that this is not a tiny edge. It's a pretty complex edge, even if it's low power, because it's a solar power chip. So if you have questions, I think you should post them. And the thing I wanted to show you after is, as you understand, it's an interesting challenge to test a complex solution like this. And actually, they have created a game to test it. So I just took a screenshot of their game. So this is the boat here that you have here. This is your problem. So that's one echo, and you have its characteristics. And when you run the system, it's gonna show up in clear language. This is what the ship should do. So what you're seeing is actually what is required to go to the captain log that the ship is actually creating as it navigates, to explain all the decision it's taking. So it's going to be able to actually, it is not going to be able, it is able actually today to do this. So every time he assesses all the situations based on the inputs, and then it will log, just like in a captain logbook, what it's going to do based on the situation. So you have a captain that's very efficient and never sleeps. So I think we're done for this. Naeem, tell us about what's coming.
Yes, so like you said, right, I mean, this is a work in progress, and the target is spring 2021 for the voyage to start. So there is lots of testing will be happening where it's located right now in the shore over there. There's a lot of system integration, like you mentioned, the integration with different third parties. Like, third party, what I mean is the other outside applications like Weather API with the AIS data, and connecting different kinds of the modem connectivities and the cellular networks. So all of that testing is going to happen. Then also the testing between some of the systems on the boat itself. So there is, work in progress. And then we have so many requests for science experiments that it's very overwhelming for the team. And so there's, because these science projects and the teams, they want live information. So it's not like you load up some scientific instrument and when it gets to 2-3 weeks later from UK to Boston, then you get information. They're saying we want the data, if possible, as much as possible, live as the boat is sailing through the ocean. So integration of all those experiment systems, like one of the experiments is that it's a 4-node Raspberry Pi cluster, which wants to do something in looking at the ocean, and they want to integrate with the main channels in the system so we can get all the information. So there are a variety of requests coming through for the science experiments. And like Eric mentioned, this is like a 10-year around the planet doing science. So there's lots and lots of plans right now. There's a lot of interest from the industry, and we'll see. I mean, there's a lot of work needs to be done.
Okay, so any questions?
So there was questions. I was looking through the chat. So one question was about the data. So yes, the data will be available openly. There might be few things which are sensitive, but majority of the data will be available for consumption. The other question was about security. So security, like for example, the secure connection between the Edge and the Edge Manager, which runs on the OpenShift platform, that's done through signed and encrypted messages in between, and then the containers which are going back and forth, the cloud native containers, right, code, that is all checked by the scanners on the cloud before they are pulled on the site. So yeah, so it's using the enterprise level security which we use on the ground as well.
Brett?
Yeah.
We have another 50 pages to explain you the details, but we didn't bring them up. It's not very nice to be not so interactive, but typically we got assailed by 5,000 questions when we present the ship. So I guess everybody's shy on the 44 participants. So you can get to us later, but I think it is at the same time a superb edge. A very typical or complex hybrid cloud implementation, and it has all the characteristics of what's happening now in the industry. And finally, it works.
So this is Sukhdev Kapoor. I pasted a question in the chat, perhaps got missed. So what happened? Let's say if you're in the middle of the ocean somewhere, and there is some kind of a failure on the ship, and you need to service it. How do you address that?
So we have planned to actually train an octopus. No, it's a joke.
No, that's a good plan. I'm all for it.
So there is nobody to service the ship like a human being on the ship. So technically speaking, everything is duplicated 3 times in that ship. Okay. At least 2 times, and most everything is 3 times. And if something bad would happen, the ship base system would actually try to maintain it in a position not to be, I would say, destroyed by the weather. And then the ship would send an emergency message. And it would take 2 weeks to get to the ship minimum. If it's somewhere in the ocean, that's kind of the average. So it is designed to be quite resilient by default. Luckily, the guys doing this do military submarines, so they know how to make stuff that's very solid. But the ocean is very strong, so there is a plan for everything is broken, and it's call for help, and there is even a plan in case the boat gets upside down. There is a system to avoid the boats to be destroyed and to still call for help if a big wave does something bad to the boat.
Yes, so the questions I'm looking at, some two more questions. One is around the Kafka streaming. Yes, so the Kafka is used as a messaging bus on the boat itself for communications between different components over there. And so we will get all the different kinds of, let's say, operational data on the boat, and we just plug into that Kafka stream through the Edge agent container, and then we pull it back into the cloud where we have another listener like Kafka. From there, as you know, in the messaging, we can pipe this out to any streaming messages, right? MQTT, NATs, whatever you like, we can push it there. But then we also have the APIs available. Next question is, are there any plans to replicate the patterns and learnings on other vessels, such as cargo ships? Eric?
Yeah, so there are already companies that are working with the shipmaker to get pieces of the intelligence solution on their own equipment. For sure, this is not finished and they need to test it, but there is a very strong interest from many parties. So yeah, the plan is, yes, there is a plan, and actually I am very sure there will be a set of products out of the AI Captain solution that is in the Mayflower, very surely available, like starting next year. They are very mature in what they've done. So yes, it will go to, we are talking to big ship makers.
Mm-hmm. And to add to that, like you mentioned about the patterns, like I mentioned in the beginning, we do plan to, we're working on this sort of like we can call a standard autonomous vessel framework, which we will publish the white paper, everything in detail, how the solution works. So we do want to create a framework for this kind of, autonomous vessels. So.
Yeah, and I would like to add a comment about replication on other vessels, larger ships, cargo ships, or whatever. There will be a little bit of applied science because as you can quickly understand, if you think about just the vision models, the location of the camera is important. The type of camera is important. When you go to a different type of vessel, you have a different type of drift and behavior at sea. So there will be, the solution is reusable, but there will be different rule set and models in the solution. They will be customized to the size of vessels, for sure. And they're already working on it. So for example, going at sea and going in a river, it's going to be a different piece of cake because there is no bridge at sea. So there is a question from Tony. Yeah, this can be applied to current ships, not for the autonomy, I think, but for having a system that never sleeps, always watch, and is able to, permanently survey what's happening around the ship and recommend the best routes. So I guess this is what's going to happen to the existing fleet, and the autonomous ships will be designed differently from the ships we have today. You have to understand that if you take a regular ship, there is a lot of space taken by the human beings just for the, being able to stay there. You need toilets, you need rooms, you need kitchen. So the future autonomous ships are being designed right now, and they are going to be radically different from what you see on the oceans. Hey, Naeem, you take the question on the open source?
Oh, what open source software is used in the solution? So let's see. Well, the thing is, the IBM's platform, like OpenShift, and these are already not necessarily like open source, but very open platforms. And technologies you can see using Kafka. I mean, these are all open source solutions available as well. So wherever it was possible, we tried to use it. But then there is also, like, for example, when you're integrating with the telemetry systems, that is not very, they are sort of proprietary systems, right? So the most thing is, as long as there are, APIs available, which we can integrate with, And that also goes for the question which was asked, what about the older vessels? As long as we have the API or some sort of way to get information from their systems, right? It should be able to do. So not everything is open source in the solution, but wherever it was possible, we applied it.
And then the edge piece, the edge management piece, is what is similar to the one called the Open Horizon. So I saw it in the charts in the beginning. So the edge management that we have into the ship as part of the OpenShift Cloud Paks is made on top of the Open Horizon code base.
I think I see
Any
a
other questions?
new question in the Q&A window. Did you apply any AI algorithms to implement your project?
Well, there is a lot. I mean, I don't know which in particular. I don't know the details of if there is any particular algorithm, but there's a lot of AI involved, as you can imagine. I don't know offhand what kind of
I cannot see the
name is.
Q&A, so I'd like to see it, and I'm going to stop sharing so maybe I can see the Q&A. Okay, I can see it now. So I'm not sure about the question. Did you apply any AI algorithm? So this, yeah, like Naim said, this is full of AI, from deep learning to machine learning to optimization systems. So the answer is yes, many. At least, I can't give you the number, but this is 2-digit numbers. All right. Naim, can you speak about Open Horizon?
Sure. So yeah, Open Horizon, this IBM's Edge Application Manager, this is based on Open Horizon. Basically, this was the work done, I think, 3-4 years ago in one of our teams. And we just have taken that code. It's still available, the Open Horizon is. And basically, it's the model of where we have the Edge Application Manager sitting in the central location. And we have all these edge nodes. And the way it works is, it's always doing a pull from the central location. So for example, if you're a developer, you go and build your application, containerized application, and you register those application with a central location, and then the edges are connecting. There's a policy which you push to all these edges. And in the policy, you define what to pull, when to pull, and what are different criteria, right? So whenever your developer goes, and let's say, for example, in inferencing, so your developer is building, just update the model for better, for improving the accuracy. The model will get updated, the container will get updated, and the agent sitting wherever it is sitting, it will know that there is an update to pull from the central location, and it will pull down that container and start running on the system. So that's how the Open Horizon was work, and now we have just added like a front end and did a little bit more things to make it compatible, running on these OpenShift platforms. So it's totally fully based on open source code, Open Horizon.
Okay, there is a question on the latency. So the ship use a satellite link when it can be connected. It's not always okay. The technology they use is Iridium, so it's 300 kilobit per second up and down link. Now the latency is not really a problem because I'm not sure I was clear enough, but all the AI is running inside the ship. So there is no you call the cloud and something happens in the cloud. The inference, the rule systems, the optimization system, this is all running in the ship. So it's on-prem inside the ship navigating, and the link is just used to provide some information about the ship situation and get mission updates. And when you get close to sea, like close to the coast, and you can get a 4G or maybe one day a 5G or Wi-Fi, then you have a much larger bandwidth, And at that point, actually, the bandwidth will be dedicated on transferring the scientific data, because they will want to upload, like sounds they have been recording, and they are going to record sounds and try to identify whales by the sounds. So during the ship, I'm sorry for this. During the ship navigation, there will be inference done on the sounds, so that the ship will only send pictures and information about what kind of whales, how many whales, and where. But they will keep recording everything, and then they will, when they are getting too close to coast, they will just download all the data, and they will use this for the scientists to improve the models for detection of the whales, for example. And I think we could spend an hour on just the current 12 experiments on board to explain them to you. But they are also using AI, and they are also like a big edge for the science in the ship. This is a very good question about computing power. We do not reveal those information, but it works very well. That's my assessment. I was inside the ship a few days ago. It's kind of pretty nice stuff. Brett, I don't know if we have passed the time.
Sorry, yeah,
Naeem and I, we can speak for 5 hours.
No, great job and great questions. I definitely appreciate both Eric and Naeem.
So yeah, you can. I recommend you go to the MIS400.com website. It's going to be, when the ship is going to do the first sea test, it's going to be live also, because all the edge system will be activated, and it's going to be fun to watch what's happening. When the ship will be coastal zones, they're going to stream pictures and video, and I guess so. Expect some improvements on the website with more data. And you can come see it in Plymouth in the UK. It's at the Turnchapel location if you want to look up on the Google map.
Okay. Perfect.
Thanks, you folks, for the time. Thank you very much.
Thank you so much.
And company.
Yes.
Yep. Thanks all. And Aaron, if you don't mind resharing the master presentation. Whoop. I think we're on the Mayflower ship video, so we can move back over to PowerPoint. Perfect. And up next, advance. We have a panel, Meeting at the Edge, cross-community collaboration to define telecom edge reference architectures, featuring Ahmad from Saudi Telecom, Beth from Verizon, and Sukhdev with Juniper. I think we have if we can move one slide, we got a presentation.
So welcome everybody to the Meeting at the Edge panel, which is a discussion about cross-community collaboration across the telecom edge. So LF Edge is obviously has a larger charter than the telecom, but the three of us on this panel are involved all in telecom type activities and how they affect how they are affecting the edge. So I'll introduce myself first. Beth Cohen, and I work with Verizon and was one of the, we came out 3.5 years ago with one of the first edge products, virtual network services. Of course, we didn't call it edge at the time because we didn't know that that wasn't the name for anything at the time. I've been involved in this CNTT, which stands for Cloud Infrastructure Telecom Task Force, or I think that's what it stands for today. And with that, I'd like to introduce Ahmed, and if you could talk a little bit more about, what's going on with CNTT and, how you're involved and how it's involved with Edge.
Great. Thanks, Beth, for your introduction. I'm Ahmed Al-Sawaf. I am working for SCC, a Cloud Data Center Senior Advisor. In terms of Edge, I'm a CNTT Workstream Edge Lead. And for Telco Edge Cloud under GSMA, I'm a co-chair. In terms of CNTT, as you mentioned, Beth, it stands for Cloud Infrastructure Telecom Task Force. In CNTT, we try to achieve a common infrastructure from its name. And this common infrastructure should be exposed by any workload and can be consumed from this workload towards the infrastructure. Especially in the Edge, we are trying to achieve. I will try to put it in this way: why we have CNTT Edge. Initially, we think about that there is no common infrastructure as the Edge that can fulfill Edge requirements in terms of, for example, accelerations or CDN use cases. So that's why we bring the idea that we need to have the common infrastructure as the Edge to start to fulfill Edge requirements. As you know, that Edge become mandated to have 5G in place. Just in a nutshell, and we can have Sukdev as well.
Sukdev, I think you have a different perspective as coming from a vendor. I'd like to hear your opinion.
Yeah, so first of all, my introduction, I'm Sukdev Kapoor. I work for Juniper Networks. I'm a distinguished engineer. I am on the technical steering committee for Akraino Edge Stack. I was on the technical advisory council of LF Edge as well. And I've been very active participant in CNTT, more specifically in the reference model, reference architecture, as well as in the Edge work group along with Beth and Ahmed. In terms of CNTT, one thing which I see is that this one body is very telco driven. It's being driven by telcos with the telco requirements, and the one thing where I see is all telcos actually agreeing to something common, to build a common platform and build a conformance program, which they would expect all vendors for both NFV as well as a VNFI to conform to, which they hopefully they're planning on making it as a mandatory as an RFPs and RFIs. So having said that, with this reference model and reference architecture, which is laid out by CNTT, it actually helps the vendor community as well, in addition to telcos. Of course, for the telcos, it makes the onboarding of their virtual network functions a lot easier and simpler. But at the same time, for the vendors too, when multiple vendors are working against the same reference architecture and working against the same conformance program, it becomes a lot easier. It becomes a lot more multi-vendor compatibility solutions. So I think it's a both win for both telcos as well as for the vendors. That's the way I see it.
Yeah,
and
I agree. Because I know, vendors always want to do something proprietary, secret sauce and all that, but if you have to build something for every single telecom, that just ramps up your costs incredibly. So I can see the real value for not only the vendors, but the real value obviously is obvious to the telecoms, but
correct.
There's good value with the vendors.
And if I may add, in terms of the overall the structure of the CNTT body, it's divided into 4 different logical components. There is a reference model which defines at an abstract level the reference model for the infrastructure, and then from that abstraction model we drive towards the actual reference architecture, which is an RA. And there are 2 RAs, RA1 and RA2. RA1 being the OpenStack based, and RA2 is a cloud native. And then for each of these—
Containerized. Let's not get into that.
Containerized, sorry, containerized. And then those map into reference implementations, RI1 and RI2, and then those map into reference conformance or compliance, whatever, it just keeps changing. So RC1 and RC2. So that's how it is organized. And then like what Ahmed mentioned earlier, that we recognize very quickly that does this architecture meet all the edge use cases and requirement, and that's where Ahmed started spearheading this new work group, which is CNTT Edge work group. And
so let's hear from Ahmed to talk a little bit more about the Edge working group, since I know I'm co-chair with it, but yes, you're doing the heavy lifting on it.
Thanks, Beth, again. CNTT Edge work stream we initiated from 6 months back, I think so. The target, as I mentioned, of CNTT Edge to start to bring and to avoid the fragmentation across all communities that were working in Edge, like OpenStack Edge, like LF Edge, which has 6 or 7 projects right now. So the target, as I mentioned, to bring all these projects in one place and to try to fulfill the requirements from telco perspective. We are focused on telco use cases, which is required for 5G, like ultra low latency, like enhanced mobile broadband, and the massive IoT, massive communication. So the target itself is to fulfill the telco use cases and to have cloud infrastructure at the edge, which is more agnostic to onboard any CNF or VNF above this cloud infrastructure.
Yeah, that's great. And I'll add that my perspective from Verizon, which is that the edge is extremely important to us for 5G and MEC and a whole bunch of other applications that are out there. So we see that as really the future. So getting back to SUPDEV, so you're on the Akraino team, the technical committee, and also quite involved with LF Edge. So how does this tie in to the CNTT? And I should add OPNFE and CNTT MELD, the new future organization. How does that align?
So Akraino is very blueprint driven. Blueprint, think of it as recipes or vertical stacks, taking a given use case and building a completely deployable, tested sort of a stack or a solution, right? And there are many blueprints which are available. Some of them map into the telco world, some of them are into the enterprise world. So essentially a wide variety of blueprints. And there are some blueprints which are very relevant to what we are doing in CNTT Edge or even in a CNTT reference architecture. So they really are addressing. So there are two the way I see the Akraino and CNTT sort of bridge or interaction is that we take a look at the blueprints which are in the Akraino community and see how they're architected, and then look back to CNTT architecture and see whether they map, right? So that way we are taking essentially a feedback from one working blueprint into a reference architecture which is being developed. So that's one way. The other way is that since telcos are going to essentially enforce this reference architecture or see what is defined by CNTT, so we want to make sure that these blueprints which are coming in Akraino, they are conforming to that architecture, and therefore it works both ways. So this is how I see both communities, the Akraino community as well as the CNTT Edge group, working together to build the bridge to identify the gaps and address them. So that's what I think.
That's excellent. And I should add also, there's other communities that we're working with, including MEF and OpenStack Foundation as well. So these are all important inputs into the edge architectures and the edge standards. Because as I have discovered, working at the edge for the last 4 years, is the edge is a superset of the cloud in that it's more difficult because there's more of them and the tools, and they're not necessarily all in a data center, nice and neat. So there's a whole lot of work needed around orchestration, automation, and managing, thousands, potentially thousands of locations with both network and resource constraints. So that just adds complexity to the problem. So I'd like to finish up with the last question. So what do you see as the biggest technical challenges to defining the edge for telco workloads? And I'll ask you first, Sukhdev, and then Ahmed, I'll ask you a little bit more about the 5G workloads and some of the other specific to telco type workloads.
Yeah, so I see multiple challenges. Of course, with the disaggregation of hardware and software within 5G world, right? The edges are becoming lot more predominant, and more compute resources and more intelligence is moving towards the edge in order to meet the latency requirements and the high bandwidth requirements and so forth, right? So that presents a lot of challenges in terms of the telco specific edge use cases, right? And now with this disaggregation effort, like all these different functions, for example, 5G core, UPF function, AMF, SMF, they could be living at different places. So it's kind of, even though there are edges, but the distinction is getting kind of a little bit fuzzy. Some of these functions could be in the core data centers, some of them could be on the far edge, some could be in the POPs, in the regional centers and whatnot, right? So that presents challenge, and in terms of how do you carve out end-to-end network slicing. So like if you were to take a telco cloud, for instance, right, and you have a multiple tenants, multiple MNOs you're catering to, and in order to carve out end-to-end all the way from the radio to on the back end to the internet or to the core data center, how do you carve out the slices? How do you carve out that so that you can ensure quality of service or your SLAs and so forth?
Well,
so
those standards haven't even been set yet.
Correct. So those are. I mean, these are the challenges which I'm sort of seeing that we as a body have to solve it, and we have to understand them and the whole end-to-end orchestration and so forth. So those are, to me, going to be the real serious challenges, and managing the edges and securing them. That's another big challenge I see, right? So with these thousands of edges which you're deploying, you can't afford to be sending drivers in a pickup truck and going and serving or rebooting the compute machines on these far remote sites. So automation. So yep. and securing,
So Ahmed, if as again from the perspective of an actual telco operator, has to deal with these in real life.
Yeah. I put it in two ways. Our 2 point here. First of all, the most of edge challenges, the missing of use cases. A lot of telcos right now avoid to make investment to have distributed edge data center across their nation or their country without valid use cases and business cases that can have solid ROI to achieve this investment. In terms of technical challenge, from my point of view, the life cycle management of of the edge is one of the most technical challenges that operator can have it right now. That's why in CNTT Edge we try to have some reference architecture and options that can facilitate from operator side to pick and choose one of these architecture. Like if we're looking for OpenStack, we can have distributed compute node or distributed controllers or centralized controllers all in one. And we have a lot of options that we discuss in CNTT Edge, as well as if we're looking for container infrastructure or Kubernetes, we can have the same architecture, distributed or centralized or all in one, to make sure that we hide the complexity of infrastructure to 5G workloads and make it just simple as much as we can to make it simple to the workload to be onboarded seamlessly on the cloud infrastructure.
Yeah, thank you. So with that, I believe our time is up. Thank you, everybody, for this enlightening panel. And I know there'll be an opportunity for the community to get involved. I encourage everybody to do that. And with that, our recording is over.
Thank you, Beth. Thank you, Sagdev.
Beth, you're still recording.
Yeah.
All right, perfect. And let's see, Aaron, if you don't mind flipping down, so we have our speaker names up and live. And we do have all three speakers on the line now. So folks, please do continue to add your questions to the Q&A window.
Yeah, we've, can I comment on one of the questions that Jonathan Gold gave? I would like to have a better understanding of what the question was. It's not 100% connected to the edge. So I'm trying to understand where it's coming from. You know, obviously a network, you know, the network is kind of the ultimate or the original edge, right? Because you're always, right from the beginning, you have edge and, but you know, as the IP networks were originally thought of, they were really not thought of as hub and spoke. They were really thought more of along the line of a mesh. You know, as applications move into the cloud, I think the networks have become more hub and spoke in terms of how the network traffic moves through them. Although, and even actually now that everybody's working from home, that's actually become even more so that it's hub and spoke, because everybody's working from their house, and then they're accessing the data centers or the cloud or whatever to pull down their applications to work. So I don't know if Sukhdev and Amit have any other thoughts about that.
No, I think you got it right. You know, that does make sense. But I didn't understand what is DQ switching. What Jonathan posted, we offer DQ switching as a standard to solve the topic of design. I don't understand, what is DQ?
So yeah, Jonathan says that's why I want to wake up all the copper to the home. So it's kind of like a universal MAC. Okay.
I see.
Well, I don't know. We're getting rid of the copper. I don't know about everybody else, but we're pulling copper out as fast as we can. So it's moving more toward fiber and wireless. So, you know, what a lot of people haven't been talking about, but it's kind of been happening under the radar, of course, is another application for 5G is fixed 5G, which kind of solves the last mile problem, because the infrastructure to support 5G or the infrastructure to support that last mile is a lot cheaper with 5G than it is when you have to run copper or fiber or whatever out to each individual location or campus.
Correct. And I think even from the radio to the DU is also being replaced replace, not with, I mean, being taken away from copper. It's all fiber.
Yeah, it is all fiber now.
1G. Yeah.
Yeah. Yeah. Yeah. 1G that's pretty typical.
Correct. Yeah.
So that's one of the other comments. That's the at home. And we're getting customers asking for to their campuses, higher than 1G. We're seeing requests for 10G.
Yeah.
But 1G is pretty typical for home. Although the US is kind of behind everybody else in that regard.
Yeah, 1G is only between the radio and the DU. After that, it's all high bandwidth.
Right.
That's
right. And it's all fiber too.
Yeah, that's where it is getting aggregated. So once it hits the DU, after that, it is like 10G and higher.
Right. Another question. Oh, I see. This is for IoT.
Yeah, and actually, if we can read it, we'll read it out loud just because I think it just went to the panelists, but for those on the line, the question was for the IoT, a DQ replaces Aloha collision detection, improving packet efficiency to near perfect. Let's see, I think there was another comment. It does the same at the lower MAC on synchronous networks too, originally invested for cable TV. Okay.
So it's kind of like an older style network slicing. Yeah, I don't know much about it, so I don't know. Sukhdev or Amit, do you have any knowledge of that?
No, that's not my cup of tea. Sorry.
Let me read the next question. Are the telcos trying to recover some workloads from the cloud providers in that movement? Yeah, I'm definitely seeing some of that going on too. Moving out of the cloud providers. I mean, remember that the telcos have significant infrastructure invested in various cloud things. So one of the purposes of CNTT is we identified a gap in the open source work around virtualized workloads, right? So everybody wants virtualized workloads, and we've made, well, for the most part, we've made the jump to VMs, but the next step, of course, is for the containerized workloads. And as we talked about in the panel, the containerized workloads, there's still gaps in the tools and the ability to do that, and a whole lot of the workloads just haven't been containerized yet, and there's some challenges to containerizing some of them. There's some security challenges. There's just the basics on the capability of the containerized tools to support network workloads that, it'll get solved over time, but it's, right now we're in the beginnings. So yeah, we're anxiously looking to containerize and move our network workloads to drop for a lot of reasons, but it's just not happening as fast as we'd like.
For the containerized workloads, the basic underneath infrastructure is all Kubernetes based, and there are some challenges and issues in terms of security as well as multi-tenancy, because multi-tenancy is near and dear in the telco networks, and because the nature of the namespace isolation, which is offered in the Kubernetes, that presents quite a few challenges in terms, especially for the vendors who are building this equipment. It does create some challenges. So we're addressing them as part of SDN solutions and so forth and adding new functionality into the CNI and so forth. So, but they're being sorted out as we go along. Yeah.
Yeah, we got another question about copper. So let me add some color about that. Copper is really expensive to maintain, and a lot of it's really old. So fiber is a whole lot easier to maintain once you put it in. So the telecoms are motivated to remove the copper. How we can sell the copper, make money at it.
All right. Any final questions for our panelists?
So we are ahead of schedule.
We are a little ahead of schedule, but thank you again, Ahmad, Beth, and Sukhdev for joining us today. And as a reminder for folks on the line, the slides and presentations that you did see today will be posted to the LF Edge wiki shortly. I think, Aaron, if we can advance to the next slide, we're about ready to wrap it. And I'll hand it over to, I think Jason is back on the line. Jason, do you hear us?
Yep, I hear you guys. Hey, so thanks to everybody for participating and the questions and whatnot. And we're going to do this again at Edge Computing World. Registration for end users is free. You can go check that out at the Edge Computing World site. It's not listed yet, but it'll be listed here shortly. And we've got some speakers from the energy space lined up as well as some other verticals. And so definitely encourage you to join that one and hear from folks directly in the verticals and what they're experiencing out there, what their challenges are, and of course, how they would like to see open source be shaped to meet their needs. So again, yeah, thank you for joining, and we'll catch you next time.
All right, thanks all.
Thank you.
Appreciate it.